In this video, you will discover a key math concept used in AI, and it will be so simple that even your grandma will understand. To understand the gradient of a hill, we need to consider both its height and length. When the height changes, the gradient changes in the same way. However, when the length changes, the gradient changes inversely. So, to express the gradient as a number, we can simply say that it is height divided by length. Now, let's think about a flat surface. What would the gradient be if you're walking on completely flat ground? The answer is that the gradient is 0. Now, one last case to consider. What should the gradient value be if you're walking downhill instead of uphill? The answer is a negative number. To wrap up this idea, let's watch a short animation. Gradient becomes really useful when we apply it to function. Take a function plotted on a coordinate system and pick a specific point on the curve. Draw a tangent line to the curve at that point. From that tangent line, imagine building a triangle with the base along the horizontal axis. You can think of this triangle as a little hill. Imagine a person walking up the hill and calculating the gradient. You can repeat this process at different points on the function to observe how the gradient changes. Until now, we've considered the 2D case, but in the real world, we live in 3D. Now, we can move both, forward and sideways, so the gradient changes depending on the direction. The gradient now consists of two values, each called a derivative, one with respect to x and one with respect to y. Let's find a way to notate the gradient. In the situation shown in this image, we might say, the derivative of the function y equal fx. With respect to x at the point x3 is equal to 2. That is quite long. So let's look for a way to make it more concise without losing any meaning. Remove unnecessary words. Use math symbols instead of words. Well, it would be good to have some symbol for derivative. Let's try guess what symbol mathematicians give for derivative. As you might have guessed, it's just d. They're not too creative. So instead of writing derivative, we put d up and down to make it clear that this is a derivative. Almost perfect. Do you know what would make our notation look super cool and make us feel super smart? Instead of using a normal d, we use a super fancy d. From now on, you know what these fancy mathematical formulas really mean. They simply describe how steep the slope is in a specific direction. Let's look at the gradient notation in the 3D case. Now, we have a function z that takes two variables x and y. So, the gradient consists of two derivatives and is denoted by inverted triangle followed by the name of function. Gradient plays a key role in training AI, like GPT and others.